So we're going to move on into 5.1. You guys all have 5.1. We're going to look at graphing sine and cosine and tangent. This is something that is very important as we carry on into your calculus-based thing. You should be able to draw sine, draw cos, and draw tan. And then we're going to move back into those shifts, those A, B, C, D thingies, or the A, B, H, Ks. Okay? So before you can do an A, B, H, K on sine or cos or tan, you need to know how we draw them. Just like we knew how to draw a quadratic, right? We knew how to draw a radical, and we knew how to draw an absolute value, so then we could shift those graphs around. We knew what x squared looked like. We knew what the square root of x looked like. So we were able to shift those graphs with the A, B, H's, and K's. So we're going to look at how do you graph sine, cos, and tan. But really, 5.1 is just graphing sine and cos. Sine and cos are very nice. They're a periodic function. What does that mean? It goes over and over and over and over again. So, can I tell you? Sine starts at 0, goes up to 1, down to 0, down to -1, up to 0, up to 1, down to 0, down to -1. Down to 0, up to 0, up to 1. It goes 0, 1, 0, -1, 0, 1, 0, -1. It just pops up and down. Blah, 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 blah. Okay? That's sine. Cos starts at 1, goes to 0, goes to -1, 0, 1, 0, -1, 0, 1. So sine and cos are the exact same periodic motion, except for they start at different things. Cos starts at 1. Sine starts at 0. Sine goes up and then down. Cos starts at the very top and goes down, down, down. Down, down, up. Sorry. So the period of a function is the length of the interval of the domain. And I don't know if you guys can guess this. The domain for sine and cos, 2 pi. Why? Because it goes up, down, down, up, 4 rotations. And basically, guess what that is? The 4 quarters of the unit circle. Pi halves, pi, 3 pi halves, 2 pi. Okay, so the period of sine and cos is 2 pi. But it can change depending on your A's and B's and H's and K's. But in general, sine goes from 0 to 2 pi. Now, the amplitude is how far it's from the middle line. Our middle line is 0. So what's our amplitude? 1. Up 1, down 1, down 1, up 1, up 1, down 1, down 1. Right? Our middle line is 0. We go up 1, we go down 1. So our amplitude on sine and cos is 1. The sinusoidal curve is a name of a curve that fluctuates back and forth like a sine graph. Sine and cos both are periodic motions or a sinusoidal motion. So I hate that I gave you the graphs already. Can I show you what I do? I don't even use a graph. I draw a straight line. Oh, maybe use a pen. Straight line. Start with 0. And then once I know the period, but the period of sine is 2 pi unless they change the period length. Okay? So 2 pi, and then I take half of that because I need to make it into 4 because there's 4 spots in that unit circle. Those 4 axes. Okay? So what's half of 2 pi? Pi. What is half of pi? Pi over 2. So then, if I need to create a longer line here, let's say, I needed to create a longer line. I go up by pi halves. 1 pi half, 2 pi halves, 3 pi halves, 4 pi halves, 5 pi halves, 6 pi halves, which turns into 3 pi, 7 pi halves, 8 pi halves, which turns into 4 pi, and we could carry on, right? What do I get at before 0? Negative pi halves, then negative pi, okay? Do you see how it goes? And then all you do is on this axis of 0, 0, you make 1, 1, and 1, negative 1 for your amplitude. Sine starts at 0, and then you really play this game. Up 1, down 1, down 1, up 1, up 1, down 1, down 1, up 1, and you get this sine graph. And it looks the same going forwards as backwards. Okay? That's how I graph sine. You need to know how to graph sine for pre-calc and also for calculus. Okay? Are we good? How would you graph cos? The same way. Period length of 2 pi, except for instead of starting at 0, start at 1, and then I go down, down, up, up, down, down, up, up. And so cos, okay, and I don't want to see no triangles. Do you see that cos and sine are pretty much the exact same thing, just shifted one little thing over? That's exactly what it is. Cos is shifted a pi halves and you make sine. Okay? Now, what else did this thing say? Does this make sense? The maximum value is +1. The minimum value is -1. The amplitude is 1. The period is 2 pi. That's how long. Now, if we go back to this picture, it's where does it start all over? Because periodic motion is where it starts over. So like right here is the starting point. It starts back over at 2 pi and does another up and down. So I actually have 2 periods of sine here, right? Cos, where does it start right back over again? It's top again, right at 2 pi as well. Okay. Okay. Y-intercept is 0. X-intercepts, every second pi. I don't know, right? Is it? If we look, x-intercepts, it's 0. It's at every pi. So if we wanted to give a general kind of thing, we could say pi n, right? Plus or minus pi n. 0 plus or minus pi n, right? Because it could be 2 pi, 3 pi, 1 pi, -1 pi. That's where all the x-intercepts are. I keep on pressing that button. And then range and domain. X's continue on forever, but your domain is popping between 1 and -1. So your range is popping between -1 and 1, so your range has to be very specific. What graph do we have underneath here? Cos. Starts at 1. Okay? So guess what? Cos and sine have very similar kind of things. It's got a maximum at +1, minimum at -1. The amplitude is 1. The period length, where do we start again? At 2 pi. Y-intercept? Let's fix this. Where's our y-intercept? It's at 1. The x-intercepts, those are wrong too. Where are they? -3 pi halves, -pi halves, pi half, and 3 pi half. So basically, Is it every pi though? But we have to start not at 0. We start at pi halves. So if we were going to write it nicely, we'd say pi halves plus or minus pi n, right? Because then we're adding a pi each time. So if we start at pi halves, if we add a full pi, we're adding 2 pi over 2, gives us 3 pi over 2. If we subtract a full pi, we're subtracting 2 pi over 2, which will give us negative pi over 2. Subtract another 2 pi over 2 will give us negative 3 pi over 2. So this statement is a nice general statement that you're going to have to start getting used to adding and subtracting. Domain continues on forever in the x's. Your range still only stuck in between negative 1 and 1. Okay? Now, I hate that I gave you the axes. Can I tell you that? You should be able to come up with these axes by yourself without me giving them to you. How can you do that? Well, you start with 2 pi like I showed you. And then you split them in half, which will give you pi. You split them in pi halves. Do we really need to know pi quarters at this moment? No, because we're only jumping by pi halves. So all this is doing is giving you a scale that's harder to read. So realistically, where does sine start? And then it goes up to at pi halves. Then goes down to 0 at pi. Then negative 1 at 3 pi halves. Then okay, this says from 0 to 3 pi, draw sine x, right? So all I need to do is come in and do my curvies. Could I go backwards?
No.
If I drew it, it would be a proper part, but it's telling me here only from 0 to 3 pi. Okay. What is pi halves anyway? 90 degrees. So it's like 90, 180, 270, 360. We're going up by 90s. That's what pi halves actually stand for. So let's try and graph this next one. It says cos x from negative 180 to 540. I still gave you lots of nice answers here. But this is 0, this is what, 90, this is 180, 270, 360, plus 90, 450, 540. I can stop writing my scale, right? I have to go backwards though. This gives me negative 90, negative 180. Where does cos start? At 1. So I write up here 1, and then when do I go down to 0? At pi halves, which is 90 degrees. So down here, then down to negative 1, then up to 0, up to 1, down to 0, down to negative 1. Am I done? Because I have to go backwards to negative 180. So then I'll draw my little graph and stop there. That's cos between negative 180 and 540. Okay? Ugh. Now I'm going to also ask you to read the graph and state stuff out of it. So, what's the period? What did I say? It's where it starts repeating itself again, right? So in this case, yeah, so period is 3.14, which is also known as pi. I'll accept both, okay? What's the amplitude? That's all it asks. State the period. Oh, wait. Let's read the question. Is 3.14 a radian measure too? You can have decimal radians and you can have pi radians, right? So actually both of these are still proper answers. What is pi in degrees? 180. So if it asked for the period in degrees, you'd have to change 3.14 or pi into 180 degrees. That's something you could just write 180 because that's a memorized kind of thing. However, if you show work and you get some sort of math wrong on your calculator, then you've got partial marks. So I won't tell you either way. I'm just saying that's how I mark. B. Did you guys find the period length there? Where does it start again? Right here. Oh, it's hard to read. Is that what it says? 6.28. Mine's really stretched out. Is yours better? Pretty stretched out crappily. Okay, so 6.28. Lots of people will just write that, and that's okay. That is its period length. Some people will notice that's 2 times 3.14, which is 2 pi. So our period is either 6.28. Oh, this is 6.28. Is that a period then, you guys? When we follow the pattern up and down, but this doesn't go back up, so it's only halfway. So this is a full period because it goes up and down. Well, we started at 0, right? So we went all the way up and back down until we restarted again. Okay, so be careful. It's not where it hits the x-axis next, it's where it's the pattern repeating. Okay? And amplitude is? So, 2, I believe. We're going to stop here. We now know how to graph sine and cos. Just regular sine and cos. We know how to find period. We know how to find amplitude. All we're going to do for homework is study for your exam. You have no assignments for 5.1. Come Monday, we're going to look at transformations. Okay?